Tycho is not only very important for the research we do here at the Niels Bohr Institute, but it's also an enormously important tool to educate students in how you use large-scale computing, and it enables them to carry out projects that would be impossible without access to such computational power.
So one of the things I'm most excited about doing with Tycho is being able to create these mock universes that we can compare with our observations. So there are many things that we don't understand about how the very first stars and galaxies formed in our universe. So what we want to be able to do is to generate millions of kind of mock universes where we can play around tweaking different parameters and see what impact they have on the universe that we then observe and compare that with our observations.
Yeah, Tycho is absolutely necessary in a time where we have almost daily observations of mergers of black holes. So one of the things that the team is doing with Tycho is to take data and trying to understand if gravitational waves are lensed by gravity, by galaxies, by clusters of galaxies. It's trying to understand if this gives us new information about the large-scale structure of the universe. It's an amazing new time for amazing new observations.
In general, we see a move in the industry and society from traditional air-cooled computing systems to water-cooled systems. And the reasons are several. First of all, you save money, but secondly, it's of course also environmentally much more sustainable. More than 30% of the electricity that would have been used on an air-cooled solution will now be saved thanks to the water, simply because it can move the heat much more efficient.
So, I think as humans we have these really big questions that we're trying to answer and understand. And so at least for me, one of the biggest questions is, how did we get here? How did our star planet come to be? And to address that, I think we really have to go back to the very beginning and understand the origins of the formation of the first stars and galaxies. And this is really kind of an area of research that is exploding now with the James Webb Space Telescope, because we can actually observe the galaxies forming in the very early universe. And so it's really exciting to be able to use Tycho to analyze that data and compare it with the simulations to understand how those first stars and galaxies formed.
Is Einstein wrong? We don't know, but Tycho will certainly help us understanding where the description that Einstein gives us ceases to be valid, if it does, and if we do find evidence for new physics, well, it's a brave new world out there.
On the mechanical side, we know that bacterial motion and cellular motion is affected by the environment, and we also know that the environment can be remodeled by bacteria and cells. But we can't actually cross-bridge those two regimes because they happen on different length scales. We hope with Tycho we are able, with these expanded computational power, that we can actually bridge it and model the entire system. So that's exactly the problem now. At the moment, because we can't bridge the entire gap, we make assumptions on coarse-grained levels of how one affects the other. So we're hoping that we can actually make models much more accurate if we can model the entire complexity of all the ranges that life exists on.
What happens when two photons collide? What happens from the gravitational point of view? And it's totally unknown because we're talking about extreme processes. We're talking about something that moves at the speed of light and may or not be gravitationally attracted. So we don't know when black holes form out of this process. We don't know if this was relevant in the beginning of the universe. Tycho will answer that.
For the young researchers, they come to Copenhagen in part because we give them a unique tool where they can break new ground by building much larger scale models than elsewhere. For University of Copenhagen, it's also important to build up a large computational infrastructure. It enables us to attract researchers that will otherwise go elsewhere. It gives people who are working in the research groups that are funding Tycho experience with large-scale computing and makes it possible for them to use it as a stepping stone towards the large European supercomputers that are only available to people who are doing exciting science and are technically ready to use, say, the exascale machines available in the European Union, and that we have already free access to thanks to Danish membership of these infrastructures, the Euro HPC.